Well, hello everybody, Tim Time Projects here, and one more excuse and reason I'm not getting that radio put back together. The poultry fence died, wasn't providing a security for the poultries, so I have a tester here, and I have it plugged in like it would be outside. I tested this outside, and in theory this little tester here should be jumping around there showing me some kind of voltage, and I see nothing. So let's take it apart. Let me unplug it first, just in case it decides to come to life. I mean, you don't get shocked enough that you're going to get electrocuted or anything. So let's see. Let's look at this. This is the... Now I did take it apart while I was waiting for my camera to boot up, but I didn't take it completely apart. Just pulled that screw out. So there's some more work to do. I just want to see what we have here for ohms on the, I guess be on the input or primary. I'm assuming there's a transformer in here. Let's see if there's volts on here just to be sure first. There's just some big old capacitor in there. 13 volts. 13 volts. So it must be something connected in here. Alright, well, we'll leave that alone. We're not going to mess any more with that because something must be connected. So this screw over here is a Torx. Looks like maybe a 15 or 20. I didn't really look at it. You have to pop the on this particular one, it's underneath a sticker, so you have, or the label, so you got to pop a hole through that to get to it. Then I think these got to come off all the way. I think. Yeah, there's no nuts here, so they may just slide through. Oh, jeez. There's all kind of critters in here. Wasn't expecting that, was I? Wonder the chickens weren't trying to eat them. I'm going to take this garbage can and throw it outside real quick. Those tabs must just hit on the edges here. So that being said, just pop it open. Let's just pop it out and see if there's anything visibly broken. I see transistor, a couple electrolytics, looks like a diode, 2 integrated circuits, a couple of capacitors, 2 resistors, so let's check for resistance on this guy. This actually looks like it unplugs. Yeah, that pulls off there. So it should be a coil on both sides. See what we get on one side. And what we get on the other side. Oops, let's put on ohms, shall we? .32 ohms on that side, and 236 ohms on that side. Come on. So I'm going to say that that's probably okay. some kind of gook all over the board here. Some, as Fletch would say, some filth muck all over the board here. See if this will zoom in if I see the black stuff all by that capacitor. Let me take that capacitor out and just see what that is. Get a Q-tip in the meantime. Coming off. Well, let's see. See if I can get that cap out of there. Let's mark. Oh, they already have the plus side marked. So they're good. Let's see. I don't know if that's blue or what. Let's take a look at this capacitor once. Say what, those leads weren't touching, they were awfully close to touching. Oh, I get it. Positive side. The negative side. Alright, saying 18 microfarads, so that's still good. Those leads had to be awful close to touching. That was weird. Also check this diode while I'm in that area. How diodes like to be. Alright. The negative side's here, so it should be conducting or doing something. Wrong meter. You come back over here. And let's see. Let's put it on diode test. 0.1 volt. And that way it doesn't conduct at all. It does conduct now. Alright, so is that because there's something else in parallel with it? Or is it a short diode? That goes to that and that. Resistance here. 124 ohms. 124 ohms. Alright, I'm going to pop that diode out too and look at that. Yeah. the other right way. Okay, so black is going to that side. We're showing an open. Let me switch this around. I'm just going to switch the leads around. Showing that's conducting. So let's see, 0.7 volts, that's about right. Throw it the other way around to confirm. And it's not conducting at all. Okay. So that diode's good. Alrighty, everything's soldered in as good as new. Well, I don't know if I'd say that, but everything's soldered in. Alright. And this guy goes like this. And then these were the contacts over here. Alright, I'm back. I cleaned that up a little bit. Let me just see about plugging this thing in. Let's get that out of our way. Let's get this out of our way. We're going to need the tester, so we'll leave that. Those can go out of the way. That's plugged in. Kids, don't try this at home. That'll be the hot side. Let me turn the light off so we can see what we got here. We got nothing. That's off. Let's just see. Come on. Range. Range. And 120 some volts. Oh. Okay. Pull it back out. Where does the juice go? R1, they call this F1. So we should be getting voltage through here and to that resistor, through the top fuse. Probably like 1 ohm or something. Let's just make sure that there's no voltage on it. Looks like there's no voltage. Just checking everything here and be sure, you know. Alright, let's look for ohms. Let's set 10 ohms. Good. Through there, through this, for 60K. Yep, that's about right. And down to that. let's put it on DC volts. And it tells me this side is negative. That side's positive. And we're going to play our range game again. Alright, it's got 160 volts DC coming out. Sure would like to disconnect it. Ooh. There we go. Alright, so that tells us that we got DC voltage all the way out. So the next thing we have to think about is what's this IC down here? Alright, let's see. I want to see if I have a signal here. You can see that. I'm trying to get this. Wish I could click the put this here. Alright, so what we're looking at here is the output to the, or the input to the SCR. And what the SCR does is it completes the path to ground. It's working now, but just a few minutes ago it wasn't. And what gives this signal is there's a chip here, and it's a integrated circuit, and it's a counter, like a divider. And it takes the input, the 60 hertz input, and I don't know how many times it divides it. I'm sure we could figure it out, but it'll slow it down enough to give me a pulse at a more reasonable rate. You know, like electric fences, they just pulse. Maybe once every 2 seconds, whatever it is. But I had no output from this integrated circuit here. And the reason I had no output was because the input voltage was down to like 1.5 volts. I'll show you where I checked it. It's at VDD and VSS. And those are the digital or the DC inputs for it. So here we're on DC, and I'll put it here. If you look now, I'm up around 13 volts. So I assumed that that was probably bad, and that's why, because all the other components, the resistor and the diode, they were fine, and the full wave regulator, their full wave rectifier was good. I'm sorry to say, the resistor and the diode for that, they were good, and the full wave rectifier was good. So I had DC voltage coming. Here's the AC, went across the fuse, through a little resistor down, and it came into this side of the coil right here. Well, the other side of the coil is the side that gets grounded, or de-energized, so to speak. And when it gets grounded, it causes the magnetic field to grow, and then when the ground goes away, it collapses again, and that's what causes the spark. Well, it was never grounding, so basically I had the DC voltage in and the DC voltage out. It never went to ground. It grounds through the SCR right here, this guy here, and as you'll see now, it works. And I'll show you real quick. I'll flip it over and show you the other parts. So here's my fence tester, and let's not touch anything, shall we? I can electrocute myself because I can't see in the dark. Okay, here we go. It's even flashing without a ground on it, but I don't know if you can see that. There you go, you can see that now, hopefully. Okay, anyhow, it's working. Take it apart. Here's the transformer that gives you the shock. Voltage comes in here, goes through, that's a fuse, a very low, I think it's like a 10 ohm resistor. Then through that resistor, and then through the full wave rectifier, and then it has the plus and minus on it. The plus comes right down to one of these terminals, and the minus actually comes through this guy, which is your SCR. Let's see if I can. Trying to get it to focus here. There we go, sort of. It's so hard to work with a camera. Alright. If it'll just stay in focus. That's the SCR. And that's just an on-off switch, basically. It's kind of like a diode that has a trigger. And every time it gets a trigger, it'll conduct. So where does it get the trigger from? Well, this guy here is basically a frequency divider. Doesn't have a lot of connections on it, so I guess that's the only pinout they had was 14. It has ground and, well, I mean plus and minus, well, we're going to say ground and source. It's source and drain actually, and then it has one input and one output, and that was it. The output controls that. So what I found was it was the voltage was very low, and what happened was all that crud that was inside the I cleaned it so that you won't see it now, but there was crud in between all these pins. Remember all those bugs that crawled out? So there's crud in between these pins here on this side, not so much on this side, but anyhow, I cleaned it out real good, and as soon as I did, I put the power to it, and I thought I heard a tick. I put the power to it and it had 13 volts, so it must have been, there must have been some crud in there that was actually grounding it out, or at least shorting more than one pin together. So that's it. So it looks like all it really needed was cleaned up, but at least I kind of learned how it worked. So when going back together, it's probably better to put it together this way, because these little legs fit underneath these tabs. I don't know how you'd be sure they were on there if you had it in here first. So you just kind of drop those down in, and then you can put these little bolts through. Come on. And then they're tightened up. Alright, and that'll hold that still. Then this part will go right on top. Goes through that little hole, so that helps line it up. And I don't have a Torx down here, so I'll just use this little screwdriver. Fits in there very nicely. It's a little bit safer to plug it in that way. Here's the ground stick. There you go, you can see it lighten up. So we're ready to go back in service with this thing. The chickens will sleep well tonight. Well, thanks for watching, and if you need to tear your electric fence apart, maybe this was helpful. Take care.